This is Chapter 3 homework for Physics 202. It's a fairly short chapter. It's just sort of leading into Chapter 4. Here I have a current of 80 milliamps, so that's 0.0800 amps. Has a metal wire. I want to know how many electrons flow past a given cross-section of the wire in 10 minutes. So T is equal to 10 minutes. I want to know what this is in seconds. In 1 minute, there are 60 seconds. So that's equal to 600 seconds. Remember, the current is charge per unit time. So I is equal to Q over T. So Q is equal to I times T. That's 0.0800 amps. Or you can think of amps as coulombs per second times 600 seconds. The seconds cancel to give us coulombs, which is 4.8 coulombs. That's an awful lot of charge. So 4.8 coulombs flows past this point. I want to know the number of electrons this is. I know the fundamental unit of charge. I just divide by that value. An electron is 1.6 times 10 to the minus 19 coulombs. And so I get 3 times 10 to the 20 electrons. A 1 volt potential difference is maintained across a 10 ohm resistor for a period of 20 seconds. What total charge passes through the wire in this interval? All right, well, Ohm's law is V equals IR. So first I want to find the current. That's 1 volt over 10 ohms. So that's 0.1 amps. And then to find the charge, as we did before, is just current times time. 20 seconds. That's going to be 2.00 coulombs. Light bulb has a resistance of 240 ohms. Voltage at 120 volts. What is the current? Ohm's law, I is V over R. 120 over 240. 0.5 amps. Part A. What is the power rating of the bulb? Well, power, remember, is V times I. That's 120 times 0.5. So 60 watts. Don't forget that we have these alternate expressions for power. So you can do any of these. In this case, you have all the information. So you have resistance, voltage, and current. So it doesn't really matter what you choose. But you can say P is V squared over R. Or you could say P I squared R. They all give you the same answer. All right. Electrical energy costs 12 cents per kilowatt hour. How much energy does it cost to burn a 100-watt light bulb for 24 hours? All right, so the rate of energy, I think energy is quite a bit more expensive than this now, but when I made this out, how much it was. So 0.12 dollars per kilowatt hour per kilowatt hour. So my units look like this, and then it's really just a matter of sort of dimensional analysis to look at how the units work out. I'm going to need to multiply by my power, but I'm going to convert that into kilowatts, so 0.100 kilowatts. That gets rid of the kilowatts. I want to get rid of the hours, 24 hours. It just leaves me with cash. So multiplying that out, get 29 cents. Do a similar thing for your oven. Now your oven operates at 220 volts. So first I want to calculate what is the power of my oven. I could just do V times I because I have the voltage and current. I have 220 volts. Why does your oven operate at 220 volts when everything else in your house operates at 120 volts or 110 volts? We'll come back to that in just a second. This is 4,400 watts. A lot of power going through that oven. 4,400 watts. So they do the same thing I did before. 0.12 per kilowatt hour. This is 4.4 kilowatts. It's your oven. It cancels out. If you want to run it for 5 hours, say you're doing a clean cycle or something on your oven, the hours cancel out. And that gives you $2.64. Right? That's a soda and a pack of peanuts. All right. Now, so why do you use 220 volts for big appliances? The wires in your house are only rated for a certain current. Right? If you put too much current through them, they're going to heat up and catch on fire. And so when we have these high wattage appliances, these high powered appliances like electric heaters, like in your central heating unit, or your electric dryers or your electric stoves, those pull a lot of power. Anytime you're converting electricity into heat, it requires a lot of power to heat up those things really high temperature. All right, so the reason we do this is so that we can keep low currents. Because remember, power is equal to voltage times current. So I have a big power, and the only way to make the current smaller is to make the voltage go up. So I make it operate at a higher voltage, so I get a smaller current. That's why we use 220 volts, or 240 volts, however you want to say it, for bigger appliances, bigger high-powered appliances. All right, how many 100-watt light bulbs can you use in a 120-volt circuit without tripping a 15-amp circuit breaker? All right, and they're connected in parallel. That means that I have these light bulbs connected in parallel. So each one has a certain current, and all of that current adds up. We'll see more of this in the next chapter. All right, when they're in parallel, the currents add up. So I want to know what is the current for an individual light bulb. All right, 100-watt light bulb, 120 volts. E is equal to VI. So I is equal to P over V. That's 100 watts over 120 volts. I get 0.83 amps. That's my current through a single light bulb. And now my circuit breaker can only handle 15 amps. So I say 15 amps divided by 0.83 amps. That gives me 18.1. So that means that I can have 18 light bulbs hooked up to this circuit, 100-watt light bulbs. Without it going out. 18 light bulbs.